Welcome back. So this is October 15th lesson. Here's our do now. Take a minute, answer it, or say if you recorded it, if you already printed it up, go ahead and solve it. Since this is a recording, you can pause me right now, and then I'm just going to keep going. So pause, work on it yourself, and then replay me, or follow me along as I go over it. So a certain canoe was advertised at having an 800-pound capacity, meaning that it can hold at most 800. And I would ask, what does that mean, right? So it can't go over 800, right? It can be 800, but it can't be more than 800. So if 4 people plan to use the canoe and take 60 pounds of supply, okay, so 60 pounds on the canoe plus 4 people, write and solve an inequality to find all the possible average weights per person that would fit in this canoe. That part's a little tricky, but we're trying to write an inequality to find all the average weights per person that would fit in this canoe. Okay, so we have an inequality. So do we have like a total or something up here? Well, yeah. We know that it can't go over, the pounds can't go over 800. So what inequality would we say here? Would we want to say greater than or equal to 800 or less than or equal to 800? Well, I think we use a less than or equal to 800, right? All right, what else do we know about the canoe? Well, we know we're taking their 60 pounds, and that's not going to change. And we do know there's 4 people, but do we know how much on average they weigh? And in this case, we don't know how much they weigh. So we're going to use X for that. 4 people at an average weight plus 60 pounds has to be less than or equal to 80. So say the 4 people, you added their weight, divided by 4, and they were 100 pounds on average. Could they take this canoe? I would say yes, because 4 times 100 plus 60, that's going to be less than or equal to 800. Could the average weight be 200 per person? So say every person averaged 200. Well, that would be no. You can't have a 200-pound person, 4 of them, because plus the 60 will be over there, right? Okay, now we're going to solve, and we should be really good. We solve inequalities just like we solve equations. And a student normally would come up 2%, but again, we don't have that. Okay, so the average weight of the 4 people has to be 185 pounds. It's okay if someone's 200, but then when they add them together, they got to keep their weight under 185 pounds if you want all 4 people on. Great. So that was a do now. If you had questions on the homework from last night, we would go over it, but this is a recording, so we're going to keep doing this. All right. So we're moving on to our next part of inequalities. Okay? And you've seen inequalities before, but this is going to should be a brand new topic for almost everybody. And I haven't said it yet in the videos, but I probably said it in class. What we're going to find in the first 4 chapters are the beginning parts of every chapter will be something you've seen before, maybe done fully before. And the last couple wings will be something new that we'll add to it. And this is going to be one of those new things, right? So this is 2.6. We're going to solve something called compound inequalities. Okay? And before we talk about inequalities, I kind of want to talk about compound statements. And compound statements are when you use the word and or. And they kind of have different things, and we're going to see them as we work. So take a moment, read both statements, and which statement is true. So I'd have you turn and talk to a neighbor, read both to yourself. When I say go, you turn to your neighbor and say which one's true or false and why. Okay. So we were talking about it. So I would say What about the first one? Is that true or false? A triangle has 3 sides and an octagon has 5 sides. Is that a true compound statement? What's your feeling? Is it? Is it not? My feeling is not, because this and seems to say that both of these have to be true. Is this true? And is this true? No, this is false. An octagon doesn't have 5 sides. So because we used and, this whole statement is false. Okay, let's read the next one. Did you think about this one? A triangle has 3 sides. That's true. The octagon doesn't have 5. That's false. What do you think about this whole statement? Can we still say it's true? And then the big key is that this is an or statement, right? The triangle has 3 sides, or an octagon has 5 sides. Is one of these statements true? Either or? Well, because it's either or, then we can say, yeah, right? 3 sides true, false. But we said or, so we can say the whole thing is true, and the whole thing up top is false when we use and or versus or. And implies both things have to work, or implies that one or the other has to work, right? Okay, so let's use that thinking when we apply to compound inequalities, okay? So, part 1, add this to your notes, and then you can just answer these, but, right? I want you to think about these 3. So what I would do, or these 4 questions, I would have you turn to your neighbor, and together you would answer these 4 parts of this question. But let's talk about this sign. You've seen signs like this before, right? Children under 6 eat for free. So I'd like you to take a moment, answer A, B, C, and D, and we'll come back and talk about it. If you're at home by yourself, try it. Pause me right now. And if you're there in class, I'd be walking around checking in with partners. Okay, so pause me. I'm going to keep going. So let's list some ages that eat for free. If it says children under 6 eat for free, what are some ages that eat for free? Someone might be, say, 5 years old. I'd be like, sweet. Someone might say 4. I'd be like, great, yeah, 4-year-olds can eat for free. And they'd say 3, and 2, and 1. And someone might say 8 months. And I'd be like, great, yeah, 8 months, you know? Could you be 5 years in 9 months? Would that work? Yeah, and then people say, oh, God, okay, we have to list them all. I'm like, well, yeah, I guess. 5 months. You could be 5 years and 9 months. Actually, that brings up a good question. What's the youngest you can be and eat for free? Right? So we could be, oh, okay. It could be 0 years, right? Or 1 minute, right? Actually, 0 years doesn't work because you're not born yet. So it'd have to be like 1 second old, right? What's the oldest you could be if you were going to eat for free? You could be 5 years and 11 months. How about older than that? 5 months, 5 years, 11 months, and depending on the month, 30 days? Well, let's even go further. So days, so you could be 23 hours, 59 minutes, 59 seconds? Sure, so we can get crazy. Okay, but you can't list them all, right? Inequalities get hard. So did anyone think of a way we could describe all the ages that eat for free? Okay, typo. That eat for free using words and the word and maybe? Any age less than 6. Cool. That's what most people say, any age less than 6. But, like, you can't be negative age, right? We can't have, so what else might we want to say? Any age less than 6, but you also have to be and, right? What's like the lowest, right? If we talk about that, any age less than 6 and, right, any age greater than 0 could work, right? So we have like this lower and upper, and that's why we need a compound with the word and, because we're going to say less than 6 and anything greater than 0. So we got to have both. So is there a way to represent the ages that eat for free using inequalities? So did anyone take this and turn this into inequalities? Right, so we could say something like age can be less than 6, and your age has to be greater than 0 because you're not born. Sweet. Okay. And did anyone think of a way we could represent this on a number line? And I would invite kids up to show what they did, but we don't have that, obviously. Well, someone might say, well, 6 doesn't work, and we got to go this way. Right, 5, 4, 3, 2, 1. But 0 doesn't work, so it goes like this. Aha. So does this little thing show all the ages that eat for free? Yeah, because you can't be less than 0 or equal to 0, and you can't be greater than 6, so this shows all that. So what we do have here, this is called a compound inequality. And we actually see them all over the place in the real world. We have a compound inequality. Sweet. All right, so I have another one for you here that you probably see all the time. All right, so if you see a speed limit in town that says the speed limit is 35, with your neighbor, could you take a moment and try to write either an and statement or an inequality to represent this? A good time to pause. Okay, what would the and statement be? Well, speed has to be is less than or equal to 35 and greater than or equal to 0, right? Can't be greater than 0. And maybe did you write it? Did you say that the S has to be less than or equal to 35 and greater than or equal to 0? Maybe someone said greater than 0. Probably greater than 0, right? Oh, can we be equal to 0? Are we breaking the speed limit if we're at 0? Maybe we could see that. Okay. So, mathematicians said, this is kind of new, so I need you to stretch your mind a little bit. We can express the solutions to the inequality x is greater than 0 and x is less than 35 in a shorter form. This is totally right. This is a way to smush together to only have one x value or s value here, right? So, I want you to think, is there a way we could take these two inequalities, this and statement, and move it around and smush it together so we only actually have one x and it kind of represents the same thing? You got to kind of like smush it in, like simplify it, because mathematicians thought there's a way to do it. Okay. So I gave students time, and they're like, I don't know. I'm like, all right, I'll give you a little clue. What if we flip the other one around? Right? But instead of x is greater than 0, 0 is less than x. This is the same. Now can you picture it? All right, what could we write? Could we smush them together? So hopefully you see that these two x's can just overlap each other. Okay, and this is another way of writing an and statement. Okay? So we're allowed to move them and squish them together to say that x 0 is less than x, which is less than or equal to 35. And x is less than or equal to 35. So, and we can check. If I put 34 in here, does it work? Is 0 less than 34? Yes. Is 34 less than or equal to 35? Yes. So 34 works. What if you're going 30? Are you okay? Let's try here. Is 0 less than 30? Yes. Is 30 less than or equal to 35? Yes. So there are two ways to write and statements. Like this with the word and, or like this down here by smushing them together. Okay. And one more time. Now let's graph the solution to see if it makes sense. So we said that 0, 35, and do these represents all the speed limit that works? I would say yeah. Boom. There we go. We got it. Okay. Let's see where we're at. All right. I guess this is a longer lesson than I really wanted, but we'll probably like do this the whole class. All right. We're going to solving for solutions to compound inequalities. So take a look. Write down these two. So we want 2x is greater than 20 and 3x plus 5 is less than 50. We want to solve this. We want to find all the x's that make this true and this true. For example, does the number 1 make this true? Is 2 times 1 greater than 20? No. Does 1 make this true? 3x plus 5, 3 times 1, is that less than 50? Yes. So the number 1, 1 works for this one, but not this one. So that is not a solution to both. We want to find all the numbers that work for both, because this is an and statement. And we can do that pretty simply by just solving. So divide by 2, divide by 2. X has to be greater than 10 for this one. We solve this one. Divide by 3. And x has to be less than 15 to make this true. So what are all the numbers that work? For both, well, it's got to be greater than 10 and x has to be less than 15. So we can throw that on a number line. Just like that. So all the numbers less than 10, 15 and greater than 10 work. Okay. So we're going to solve this inequality. Well, this is an and without the word and. So what are all the numbers that work here? 5 is less than x and x is less than 15. So what numbers can we put in here that make this true? Does 10 work? Does 20? What are the numbers that work? Cool thing is, you can rewrite this as 5 is less than x, and if you can read it, x is less than 15. So there are two numbers, and the cool thing is, we have our answer if we're going to graph it. All right, the last one that you're going to see for notes, and then I'll get you to practice. You're going to have to solve this one. You have to find all the x's that make both of these true. If I put a 1 in here, does it work? 2 in here, does it work? 3? I don't know. Well, someone needs to read this. Can you read it for me? Well, 5 is less than 2x plus 3 and less than 15. But what has to be less than 15? Well, the 2x plus 3 has to be less than 15. So we're going to use the inside twice. Because remember, it was smushed together before. So we're just going to pull it apart, and we'll have 2x plus 3 twice. Okay, now we just solve them both, and we can find all the x's that work in here. Minus 3. X is greater than 1. minus 3. X is less than 6. Okay, so our solution is 1 is less than x and x is less than 6. So we can put them together. And it looks like we know that all the numbers between 1 and 6 work. There's our solution. You could have written it like this or like that. Okay, I hope that helps. And we're going to spend a couple days on thinking about it, so it's okay. All right, your classwork here. Homework here. Okay, homework, it looks like a lot, but it's only, I think, 1, 2, 3, 1, 2, so 5, 6, so 7, 8, 9. So only 9 problems you're solving, okay? So take a moment in class, work on this. We'll go over the answers if you were live in class, and I'll post answers to it. And then homework right here, we'll go over tomorrow. Okay, I think that's it. Let's see. Oh, yep.